Okay, guys, thanks again for coming. I think it's time to begin. So first of all, I have to say that I'm very much, I don't like very much the online format of events. Several years ago, when the Corona started, I actually had a presentation in PyCon Israel about serverless technologies, but due to Corona, it was moved to online. That was a very bad experience for me, although I had presented, but I really think it's the wrong way. All kinds of presentations should be face-to-face, should have interactive activities and so on. So I would really appreciate if at least some of you who are not currently naked or improperly dressed would turn on their cameras so that I could see you. Again, that's not just a request from me. Thank you. So a little bit about myself. I'm Nick. I live in Israel for 10-something years, and I worked as an engineer and as a manager in different hosting providers, cloud providers back in Russia, and since 2005 or something. And I've been always programming. So since I moved to Israel, I started using AWS on a daily basis for, it makes 10 years already. Before that, here and there, some S3 buckets and so on, but for the last 10 years, I've been using AWS, again, on a daily basis. I know plenty of their technologies and architectures and so on. So I have also developed hundreds of Lambda functions. We're now talking about AWS Lambda 2014 till now. So that makes almost 10 years, 9 of which I've been writing Lambdas. Okay, so let's make a brief recap of what Lambda is. I'm not going to tell anything about the technologies underneath Lambda. For that, there are different kinds of events, mainly educational events, but here I assume that everybody knows what FAS is, and we'll just discuss how it evolved. And feel free always to send your messages, questions in chat. We have Evgenia here who will help with answering some of your questions, or later I can, we'll have some Q&A or something if you like. Anyway, let's go on, and let me find the button to go to next slide. Just 1 second. Okay, so as I said, I have attended different kinds of AWS events, re:Invents included, and all kinds of deep dive about the Lambda. And I want to say how the Lambda actually appeared, at least in my opinion. So serverless now, today, it's much more than just Lambda or than FAS technology. It's more of a way of thinking when architecting applications. But under the hood, even Lambda function is just another way of virtualization. So one of the key values of the virtualization is improving resource utilization to have less idle time, more effective time. And Lambda moves it to a different level other than all kinds of containers or on-demand instances and spot instances, whatever else. Because in Lambda, you physically utilize only the time that that your application is running. No idle time, or at least we can assume that. And another way is that Lambda, another way it's changed the reality is that Lambda gives developers a way to focus on the code and on the application they do, and it requires much less DevOps involvement in order to make serverless applications. And managed services is always good. So what you can delegate to the cloud provider, that's you should delegate to the cloud provider. And no, of course, with a small FaaS, with technology of FaaS, with small let's say, pieces of like AWS themselves sometimes in a couple of events I heard call this not the microservices but nano services. So once they are small, you can much easier scale them. And again, this happens all managed by AWS, so we don't care much about balancing, scaling, and things like that. Okay, so where are we? 2014. 2014, and here how Lambda technology looked when it was initially introduced in November on the reInvent 2014. 1 gig of RAM. By the way, today, who remembers how many, what is the biggest size of the Lambda function runtime? I think it's 10 gig or probably 16, something like that. The execution time, max execution time back then was limited to 1 minute. Today it's 15, and probably it will stay like that for quite a while. But there were also a couple dark moments. The dark moment is that back then, creating Lambda containers, Lambda sandboxes, as they called in AWS terminology, could take quite a long time. And for the last 10 years, AWS have been working on different ways how to make it faster and better to minimize the cold start time. But there were several breakthroughs. We'll talk about them today. Of course, today you also can, for some extra cache, have warm instances reserved. And in this case, the cold start will be, let's say, minimized. And back then in 2014, Lambda supported only one runtime, Node.js. If I remember correctly, 12 or something, but that it's still Node.js. And that's why I had to wait 1 year before I could write my first Lambda, because I'm not a JavaScripter. I use different language. That's why only in 2015 I started my experience with Lambda. I will later talk about runtimes a bit more. But before the runtimes and the evolution of Lambda, let's see how the event-driven field looked before the Lambda, because Lambda will in serverless architecture will be very, very tightly connected with the whole idea of the event-driven architecture, and we'll even we'll talk about it more. So back then there was Q, and I was surprised today when preparing for this presentation. Sorry that today I did this only this morning, but I was surprised to learn that SQS was actually introduced in 2006. That's a very long time. It was the same year as S3 was publicly available. That's a long time ago. But anyway, queues, pub subs, SNS, and Kinesis were already in the market and were already utilized in applications working in different compute environments other than Lambda. So from EC2s, you could use SQS and other compute resources. But Lambda Lambda changed it. And we'll talk a bit more how exactly it did. But what is actually event-driven? Event-driven is a bus or message broker there is a publisher or event generator who sends event to the bus, and there is some kind of subscriber, worker, whatever it's called, who will consume the event, process it, and do whatever is needed. But the idea is that buses and event-driven technology lets you decouple services, decouple producers, event producers from event consumers. And that concept was actually opening a huge fertile field for developing microservices, because otherwise it doesn't make much sense if your event producer will be some monolith application and event consumer will be another monolith application. You can't really gain any benefit from whatever broker or bus will be in the middle, because they will still be the bottlenecks themselves then. And here comes the Lambda that was designed to scale exactly to the width of the event stream or event channel, whatever channel this is, to be able to process these events. And during here I have a list of several functions, several AWS services that were designed, that were actually introduced when the Lambda was already in the market. And they were, in a way, designed specifically to be able to work with Lambda technologies, with fast technologies by design from the start. And there is, like I mentioned, that Kinesis was already in the market. Kinesis is a streaming service managed streaming service that actually is quite similar to Apache Kafka. And back then, people were still using Kafka for quite a long time after Kinesis was in the market and after Lambda Functions were processing these events from this event channel. And in 2018, AWS introduced the managed Kafka. And now I still don't understand how it really, for such a long time, how these two services could live side by side. But this gives, managed Kafka and Kinesis itself. So this gives just a wider variety of tools to choose from AWS infrastructure. And of course, there is DynamoDB. And DynamoDB was even some years, DynamoDB was competing with AWS Lambda, which one of these will be the fastest growing service in AWS. And I remember that in several reinvents back then, in 2015, 16, they were always competing, because DynamoDB was like, in many applications, it works side by side with Lambda. So very soon, as you can see, in 2015, DynamoDB streams were introduced, which is actually a pipeline to stream events from the database to the Lambda functions. So, 2015, a little bit step back. Step Functions. Step Functions is one of the few quite questionable services of AWS, in my personal opinion, because, like, first of all, what does it do? It's a state machine that helps to orchestrate workflows that will be processed in the serverless environment using Lambdas. And it allows you with even they even have some specific language for these workflows by AWS to design quite complex scenarios. But under the hood, this is still a state machine. And in the initial, like when it was designed in 2015, it was actually using a physical EC2 back then. And no, it was under the hood of the AWS, but still it's the same EC2. So I even asked ChatGPT today whether he considers step functions to be an event-driven mechanism or not. And this is one of the few times, actually, for me, it was the first time when ChatGPT said, I have two opinions, choose which one you like more. And one of them said that although like you can consider step functions as a event-driven service because the producers, step functions, sorry, as an event-driven mechanism because the producers of events to invoke step functions are usually event-driven, but under the hood it's still not. So a whole field for philosophical discussions here. But another one next year after that was a service that changed many things in the world of IoT. IoT back then, Internet of Things, was growing. There were a lot of devices. Now we have it everywhere, but back then there were, let's say, fridges connected to the internet were coming to the market. But for example, farms, all kinds of sensors didn't have that broad connection to the internet. So for these services, AWS introduced the Greengrass, which could run cloud infrastructure and integrate with cloud infrastructure, running applications and collecting events and actually being triggered by these events from the on-premise ground. It could be AWS Outpost, and Greengrass was initially designed to run on outposts. So Lambda from day one was able to run locally on outposts in the data centers or locations of the customer and work with IoT events then. And at the same year, the same event actually, I don't remember if the same day of the event, but probably maximum with a difference of 1 day between them, SAM was introduced. And SAM changed the way how developers had to work with Lambda functions and with infrastructure as code. Because developers were always crying that the entry level required from them to start designing, not writing, but designing Lambda functions and Lambda-based applications was pretty high. They had problems with testing. They had to deploy these Lambdas to the cloud to see that they had some syntax error and things like that. And SAM changed that because it gave a possibility in the initial phases to run local testing to simulate the environment in which the Lambda will be running. This was a big helper for the serverless developers. What changed even more is that with years, SAM introduced many different templates to design applications. And they have even a repository of where developers could publish their custom-made applications. And SAM itself in GitHub has huge amount of examples where you just take a specific solution that you need, deploy it to your account, and it runs with two commands like sem build, sem deploy. So it's a very, very useful squirrel here. But that was still not a game changer. The game changer, the real game changer, was in 2017. And this is the year when I even had to write some JavaScript myself. Because the first year, no, not the first year, it was even for several years, the Lambda Edge could run only in Node.js environment. But what does it do? Here, like, first of all, applications, most applications, okay, not most, many applications are web applications. And many web applications run through CDN, Content Distribution Network. Speaking about AWS infrastructure, this is CloudFront, which is quite a big CDN. Not the biggest one in the world, but quite a big one. And back then in 2017, it was already one of the biggest one. So AWS allowed moving some of the simple processing to the edge locations of the CDN. So you can, if we imagine that this box here is the edge location, then there are 4 points where you could trigger custom Lambda functions. And the viewer request and response are run exactly here in Herzliya, in case you are in Israel. The origin requests and response, they run in some further location in the level 2 of CloudFront. But anyway, they shouldn't go to your region where your origin resides. And the origin, here I showed several possible origins, like EC2, Lambda, could be all kinds of balancers, even static for S3 for static. But origin can even be a mock, because once you could do some computing, processing your request and modifying your request and response, you could generate the content to return to the user even on the edge location. And this greatly increased the hit rate, user experience, and that was a real game changer for web applications. So this was back then. There was no Python. Now, I don't remember exactly when, maybe 5 years ago or something, the Lambda Edge started supporting 2 runtimes, so it can run both in with Node.js and Python. And okay, what do we have? Lambda Layers. Lambda Layers 2018. In 2014, if you remember, one of the pain points of Lambda, of running Lambda applications, was the long cold start time. Because especially if you have a big package, you have to download this package to your Lambda container by network. So Lambda Layers under the hood is actually just a EBS that contains your code and that is mounted to the Lambda sandbox if you configure it. It's of course mounted read-only, because the same storage can be used by multiple sandboxes and by multiple Lambda functions even. But it really changed the way how people started packaging their code. So all kinds of libraries external that you need, you can keep in the layer. They will be quite quickly, actually very quickly, mounted to your sandbox, and you don't even have to rebuild your packages every time you have some changes to update versions of some imported library that you use. So about layers, what's next? Okay, runtimes. I promised to speak a little bit about different runtimes. Of course, I don't have any versions here because all these runtimes support over the years different versions. Some new ones come to the Lambda infrastructure. Some old ones are deprecated, but one big thing changed in 2018. As you can see here on this slide, there are 3 different runtimes that were introduced during the 2018 year. But also at the end of the 2018 on the reInvent in November, there was another big announcement. Lambda Functions started supporting custom runtimes. This means that you could create your own image of the runtime environment, upload it to AWS, following, of course, a lot of different rules and limitations. But as a result, you could physically run write your Lambda functions with, I don't know, Turbo Pascal. So it became Lambda function in that moment in 2018 became language independent. That was a very important change for different kinds of applications, because there are some that need heavy libraries and need different languages. And you can't install all of that in your Lambda package. With custom runtimes, you could do that. But in 2020, you could do even more. You could physically create your own container with any kind of code, dependencies, whatever you need, and run your Lambda functions in these containers. Of course, utilizing all the features of the FAS. So it's not really running your containers. It's running Lambda functions in your containers. And in this case, you're also build and you pay for the execution time of the function. And you get all the things that are around that, like event processing, scheduling, keeping warm, and so on. So for this made let's say, places where you could utilize lambdas even broader. And okay, this is a different topic. Let me take just once. Yeah, 1 second. Sorry, I was talking about networks. Just a quick recap of how lambdas could work with networks. Initially, Lambda functions had network interfaces, only the public ones, and were running outside your VPC environment. And so they could, of course, work with all kinds of AWS services, which are publicly exposed. But for example, if you have a private database server somewhere inside your VPC, you couldn't connect to that service from a Lambda function. And in 2016, that changed, and the Lambda functions could create network interfaces inside your inside your VPC. But this was quite a painful project, painful process, because creating network interfaces, ENIs, takes time, and you can't change it, you can't create it faster than your network equipment will make the virtual network interface. Also, ENIs take IP addresses. So you have to keep a big enough pool of IP addresses in the subnet that will be used for Lambda functions, because as we remember, Lambda functions can have multiple concurrent executions. There could be many sandboxes, and each one of them will take some IP addresses. So that was also quite a painful moment when working with VPC interfaces. So you always had to think whether you need VPC access or not for each specific function. And of course on security, because of security as well. And it took 3 years for AWS since they introduced access to VPC to solve that problem. And they solved it with reusable ENIs. So ENIs were now in the created absolutely separately from the sandboxes. They were kept warm in the infrastructure where the Lambda will be created with the Lambda sandboxes, and they were very quickly attached. This was a game changer for Lambdas that were working with network, because the IPs were now static for these ENIs, and they were reusable. And of course, there were several other network upgrades for Lambda functions, and one of them was EFS integration. So Lambda functions could work also with the EFS. It's actually a NAS by AWS as a service, so network disk. And here is a small list of a very small list of AWS services that work based on Lambda functions themselves under the hood. And during the years, AWS was utilizing more and more Lambda mechanism, and they built and rebuilt many services themselves. As you can see with the blue color, cyan color, there are databases. And many different, like all these databases, TimeStream, Neptune, Redis, Parquet, all of that was now supports serverless versions of databases. And you could ask, why the hell would I need some serverless Aurora when I have already my RDS Aurora working perfectly? So this is very useful when you have unpredictable access patterns, and when you need to keep an eye on how you optimize resource utilization. Because for databases, that is one of the very painful points, because databases quite often have to be provided with a lot of extra resources. So with serverless, when under the hood, it's Lambda functions doing that. And Lambda functions, not your Lambda functions, AWS Lambda functions. This makes the databases very cost effective, especially with unpredictable and irregular access patterns. And of course, there are many other services that were either initially built with a Lambda function under the hood, or were rebuilt by that, like Fargate for your machine learning, like Event Bridge, which is by design from scratch built. You remember I mentioned in the beginning that Event Bridge is how the event-driven message broker, event broker, was built. So Event Bridge is the message broker service, and it is fully serverless under the hood. Okay, so this is just, have an infinity sign here. This means that more and more services will appear. And of course, this slide just doesn't cover even quarter of what's running serverless in AWS itself. This is actually the last slide. So lastly, I wanted to say just one thing. And this is just the first paragraph. If you think that serverless ideology doesn't apply for your specific applications, and it will be better run with containers, EC2s, or physical servers, or whatever else, you just don't know how to utilize serverless technologies. You need to rethink the way how you architect your applications, because there are very, very, very big examples of AWS itself included that you can build almost anything better with serverless under the hood. And read some AWS best practices of how to do that. Well-architected framework, AWS, well-architected, oh yeah, I didn't write it here. Well-architected framework is a set of articles where AWS describes how to design the applications correctly to utilize the best of the AWS environment. This is a table book for any architect should be working with AWS environment. And lastly, a little bit about Nick mentioned in the last two paragraphs. Nick is me. So I do, I see that we have a link here sent in the chat by Evgenia. So the company SOSW is providing training for developers, for architects of how to design applications in the serverless environment correctly. And we also do some consultancy with architecture. So feel free to call me. I will share my ideas about how we can make your project better if you have some uncertainty about that. And thanks again for coming. I'm going to make this meetup group, Serverless IL, much more active than it was before, because the last event we had in 2018 and didn't really use it much after that. So we will. And thanks for coming again. Now I'm ready to answer some questions. So let me see if we have some. Chat. Any tools to convert lambdas to GCP functions or Azure functions? How to avoid vendor lock? Yeah, I see that Ivan suggested the serverless framework. Yeah, that's one of the ways. I don't know why Andrei just suggests to use Kubernetes here, because it's a different technology, not really a way to avoid vendor lock here. Look, there are Terraform, there are serverless framework that allow you to, it's not about converting lambdas. Converting lambdas, you don't really have to have any pain converting lambdas. The problem is probably with converting the rest of the infrastructure you depend on, queues, whatever else. So yeah, for that you can use Terraform, serverless. That's a good option. Okay, do we have any other questions? Should the recording be available after the meeting? Yes, I think we can publish it somewhere. At least I think the recording is currently in progress, so we'll publish it. That's it, right? Okay. So if you have any other questions, call me. And thanks again. Bye, guys.